Passing the Claude Certified Architect exam requires a very specific architectural mindset, not just rote memorization of API endpoints. By building the Lab 1 customer support agent from scratch, you will physically hard code this mindset into your muscle memory. To follow along, you need 4 things: Python installed, an Anthropic API key, a $5 budget, and the cloned Lab 1 repository. Hands-on building is the most reliable way to internalize the logic required to accurately spot correct answers on test day. Let's get started. Before writing any code, we need to understand the framework. 80% of the exam questions test your ability to recognize a specific architectural pattern over raw syntax. This framework relies on 5 key judgments, but let's look closely at proportionate response. When a system fails, your first fix must always be the smallest, most direct mechanism addressing the root cause. The exam uses distractors to test this discipline. Trap answers frequently suggest using sentiment analysis to route frustrated customers or relying on the model's self-reported confidence scores. You will also see options to simply use a larger model or expand the context window to fix an architectural failure. Because attention dilution and unclear criteria do not yield to more tokens, those choices are always incorrect. Eliminating these specific anti-patterns makes finding the right answer almost automatic. Now we apply this to the code. We start out with a basic agent loop equipped with 4 default customer support tools: get customer, lookup order, process refund, and escalate to human. When we run a test query, the agent confidently misroutes the request and selects the wrong tool. Our initial tool descriptions are deliberately vague. The immediate instinct might be to build a complex machine learning classifier to route requests, or to add few-shot examples to the system prompt. We applied a proportionate response rule instead. We fixed the tools directly by expanding their descriptions with exact input formats, intended use cases, and strict boundaries. Running the exact same query again, the terminal output shows the agent routing the request perfectly on the first try. The model relies primarily on these descriptions to make its selection. Upgrading your text descriptions is the most direct architectural fix for routing errors. Let's look at another requirement. The system must verify a customer's ID and strictly block any refunds over $500. If we try to enforce this probabilistically by simply adding a rule to the system prompt, like telling the model to block high-value refunds, it will eventually fail on a complex edge case. Natural language prompts cannot guarantee strict compliance. They operate on probability, making them completely unsuited for financial or security operations. We need to apply our first core judgment and use a deterministic programmatic hook instead. We write a Python function that explicitly intercepts the outgoing process refund call. When we test a high-value request now, the system perfectly catches the refund attempt and safely hands it off to our human escalation pathway. Whenever business logic, money, or security is on the line, code-based hooks are the only correct architecture. As our agent interacts with the customer, it continually extracts data. We have to validate that information before relying on it. The agent returns a perfectly formatted JSON schema block. This is structural validation. However, perfect syntax doesn't guarantee the values make mathematical sense. We add a semantic validation layer, routing the JSON into a Python script that rejects it if calculations are wrong. You must separate the shape of the data from the truth of the data. Robust architectures never assume information is accurate merely because it is cleanly formatted. Let's execute our completed agent script one last time against a complex, multi-turn edge case. The sequence executes exactly as designed. The ID verification succeeds, the over-limit refund is instantly blocked by our programmatic hook, and the structured data smoothly escalates to a human agent. By building this tool, you have successfully translated those core architectural judgments from abstract theory directly into execution. Now take this identical mental model to the GitHub repository and tackle labs 2 through 4. The true mark of a certified architect is the ability to build resilient, reliable systems. Master the build, and passing the exam becomes